Okay, so question 5, we had a microwave transmitter and we had it going through a double slit, and it was asking why we have intensity maxima observed at X and Y. So again, when we got maxima and minima, we always want to mention they're superimposing, okay? And in this case, because we're talking about maxima, I'm going to mention that they are giving constructive interference. Okay, because it's saying explain, I need to give the reason why we have constructive interference. So in this case, I'm going to say we get constructive interference when the waves are in phase, okay, or when they have a path difference of n lambda. Okay, so 1 mark for saying that one, and then 1 mark for saying that part. For part B, it was saying then the distance from S1 to Y is 1.243 metres and the distance from S2 is 1.18 metres. What is the frequency of the microwave? So I'm going to be using the equation V is equal to F lambda. Now, at this point, if I know the two distances from the waves, okay, which I can see here and here, I can calculate the path difference. Okay, so the path difference between these two waves are 0.062 metres. Okay, now if I go back to here and I count my maxima along, so this was the first one, so 0.1 and then 2. So this would be 2 wavelengths to get to this point here. Okay, so this path difference, okay, that we have of 0.062 is equal to 2 lambda. So 1 lambda is equal to 0.031. Okay, at this point I'm going to rearrange for frequency. So I've got velocity divided by lambda. Okay, so 3 times 10 to the 8 divided by 0.031. The reason I'm using 3 times 10 to the 8 is because I know this is a microwave and we assume all electromagnetic waves travel at the speed of light, which gives me the final answer of 9.7 times 10 to the 9 hertz. Okay, so you've got 1 mark for getting the path difference, 1 mark for then finding the wavelength, and then 1 mark for your final answer. The next part then says outline one reason why the maxima observed at W, X and Y have different intensities from each other. Well, we know that intensity varies with distance. It actually has an inverse square law. So intensity is proportional to the inverse square of the distance. So basically, as I go along, the intensities are going to decrease because we're travelling different distances between W, X and Y. The last one for 5D was about polarization, and again this was talking about having my receiver multiplied through different angles. So we were starting at 0, moving it through to 90, moving it back through to 180. Now it tells me at this point that they have already been polarized, so as it goes through, I'm going to start at a maximum intensity. When I get to 90, because it's being polarized and they're at 90 degrees to each other, they're going to completely cancel out, so I get 0 intensity. Moving back around to 180, I get maximum intensity, and you should have a cos squared graph shape. So you've got 1 mark for having 0 at 90 and 1 mark for a cos squared shape graph.